Typically, the projects that require technical definitions assemble inputs of specific areas. The constraints of one silo then becomes the constraints of the whole system, pulling down the expected performance. Predicting and assuring the reliability and performance of the whole system when the key design elements have been defined by parts, normally on Excel sheets becomes nearly impossible. That's where simulation comes into play. Simulation is representing a system, which is an array of processes, using a software to understand it and improve its performance. It is widely used by best-in-class companies to design and improve complex systems. It allows the team to control experimental variables under low risk, low cost, all in a 3D environment. This is really simulating the supply chain, first part of the simulation series. Your best source for simulation tutorials and references. I'm Enrique Lizaga, Head of Simulation Projects at Supply Chain Institute, and I'm very excited to help you become a simulation expert. Block 1. Really simulating the distribution center. We will do a second pass to our inbound flows and create an inspection process. Please remember to take your notes. We will be helping you at the beginning and at the end of each video to remember the key concepts that you need to remember. Remember that you can download the project assets in our webpage. You scroll down, click on the block and the session that you want to check out, scroll down, and you will have all the assets and files to be downloaded into your hard drive. I want to change the inbound buffer appearance, and I'm going to do that by loading a different 3D shape and then also changing the texture for the object. FlexSim can take lots of different files, different shape files, and they keep adding more, so there's a lot of options for you. I will use white color so that my texture looks perfect, and it's gonna look like some lines on the floor were painted. The visual impression for this is pretty sweet. This way I'm giving a little life to my model. So this way we're gonna have great DZ visuals. Remember that our media files are available in our website for you to download. When I first started modeling, what I would do is I would add additional shapes to create the scenery. But you don't really want to keep adding new objects since you have some visual objects that you are using for your process. So something that I do is I take advantage of the already existing objects and I change their shapes and their visual textures so that they will resemble something characteristic about my process, location, or layout. In this part of the model, once I've loaded the truck shape, I am resizing it, locating it correctly, and rotating it so that it serves the purpose. This way I have a trailer to unload, and I'm gonna keep it a couple of feet apart from my buffer. Then I'm gonna work with the other shapes too. And I'm gonna use the shape for an inbound truck door. Let's see how this looks like. We're gonna run the model. Wow, yeah, it looks way better. A lot of style there. Good. Something that I don't like, and you're gonna get comments when you're presenting your model if you don't do this, is the obvious ghost forklift. And we can get rid of that effect by introducing what is called a path network. It's basically an arrangement of nodes connected to each other that serve like roads or train tracks. This way the objects will not walk out of their paths and run into other objects. Please don't forget that you will need to connect those nodes with the A key and also with the objects that we will be interacting with, in this case the rack and the buffer. They will display some blue lines connecting with the path network, and then we will connect with the task executor, in this case the forklift. The line with the connection will be red. This is the desired effect. So product doesn't just walk into the DC and go to the final location. Usually there's a small or large inspection process. So now we're going to add that new feature to our model. So what we can do is we will create a logical process that's going to happen at that buffer. But we'll do that by introducing a huge concept for modeling, which is the process flow. It got added a couple of years ago by the FlexSim team, and it really bumps up FlexSim's capacity to basically model anything you want. Here we go. Because the process flow needs an additional workspace, what I'm going to do is I'm going to use this graphical user interface tool to choose what side of the screen and what size I want my process flow workspace window. Because the alternative is switching between tabs, and well, that will not do. As we had a library of objects for the 3D workspace, if you click on the process flow workspace, then the library is gonna change and you're gonna have some different elements to work with. There are different kinds of process flows. This time I chose a fixed resource process flow. It's gonna have a relationship with the actual buffer. And we do that by connecting or sampling the object with the sampler tool. It will also remove this message that says no object attached. What are we doing here? This way, the buffer will carry out any activity that the process flow details when we tell it to and how we tell it to. How are we going to want to do this? So we're going to bring in an event triggered source, because we want the, let's say, the process to happen or to start whenever you start receiving pallets over here. That's the whole idea. You want to do the inspection of some pallets that have arrived. So let's sample the queue right here, and we're gonna choose just arbitrarily on entry. Every time this inspection process starts, I know which is the pallet that I'm working with. So I'm gonna create a label called pallet right here, and I'm gonna assign it to my token. Assign. Okay, and my token name will be palette, for example. So we're gonna create, this is another hack. Let's create a delay right here, and we're gonna use that delay as an audit tool to see at the end of the process flow if the tokens and the activities behave correctly. So what is a token? Again, I will introduce a keystone concept for process flow modeling. Tokens are the conceptual markers that walk through the process flow diagram. Its blocks of activities are visited one by one in sequence, and they trigger every activity that has been specified. Typically, many tokens can flow at once, setting multiple gears in motion. They do so by using token labels. In those labels, we can practically record any kind of information. In this time, we're pointing towards an object, the palette. In order to carry out my inspection process, I want to keep my palettes inside the buffer, let the operator approach, do the inspection, and then after the inspection is successful and completed, release those palettes to the next stage of the process, in this case the rack. So I'm going to be using an activity called batch. This is only for collecting 10 tokens. Remember, the tokens are, each of them are linked to one palette. So in this case, I will be collecting 10 palettes. So I drag a custom code activity into my process flow for closing the output ports, which are actually like doors to leave the buffer into the next activity. And I'm also gonna close the input ports after I'm done collecting my 10 palettes. So we go to the drop-down menu, we choose Control, and then Close and Open Ports. For the first one, we're going to choose Close Output Ports. For the second one, Close Input Ports. Just to make sure that after I finish the inspection, the buffer can be cleared by the forklift and no other pallets are gonna be coming in before the forklift clears all the pallets that are inside that buffer. I do this because I don't want to mix the pallets that have already been inspected with the ones that haven't been inspected. It closed the output, and I have not opened them yet, so that's why the forklift is not taking the pallets away. So now we're going to be creating a label where we can store the information for the token that points to both the operator and the other objects that it's going to be interacting with. So I'm going to pull the assign labels, and I'm going to create in the token a label called picker. And since the first moment, I'm going to make sure that I want to point it to this guy. There's two ways of doing it. I could use the sampler and just make sure that it uses model.find. It's just that jargon. Or instead, remember that I told you that we could use this connection that exists between the process flow and the queue. So I'm going to be using that. How do I do that? First, I make sure that I have a center connection from between the buffer and the operator, and it's going to be the connection number 2, because the connection number 1 is the forklift. There's going to be connection number 2, center object connected to the port number 2. So right now, what I'm going to do is, because this process flow is connected to the buffer, I can use the word current. I reference the current object, which is this one. Remember, it's already connected, or there's a connection between the process flow and the buffer. And I can make sure I reference something from current, and it's as you maybe thought of it, I'm going to reference the center object connected to the port number 2. So if it's purple, that means it's working okay, and the number of the port is going to be inside brackets. Okay, so I'm going to make sure that I audit that right now, but I want to audit 2 labels actually, which is the buffer and something happened right there, and the buffer is gonna be the current object. It is possible that I might want to have this before pointing to the operator, because I'm explaining what current is first, right? So this is exactly what's happening. Let's talk a little more about these token labels. Token labels can carry different kinds of information, as I've said before. For example, you can point to an object by using the word current, and it will get the address of that object and point towards that address, and you can change or the attribute or do something to that current object. In this case, the current object would be the buffer. You can also point toward connected objects, like we're going to do by pointing toward the center object number 2 in this case, which would be the operator. You can point, of course, toward other objects by using their names, their full addresses, and you can do that by using the sampler and sampling the object. You can also point toward flow items by using the commands first or last. And what Flexim will do, it's going to go to current or to the object that you have selected, and it's going to look for the first object there or the last object there. It could be a box, it could be a palette, it could be anything that's inside that object you pointed to. And finally, you could use the token labels to, for example, manipulate data like numbers. It's very handy when, for example, using counters in cycles, and you can iterate through that counter from 1 to 10, 1 to 20, or backwards, or any other kind of data like an item type, like the SKU ID, the SKU name, description, shelf life, price, anything you want to store in that label. So as you see, the buffer is this object right here, and the picker is this object right here. So we're doing it correctly. And you're learning to use labels. Labels are very useful tools that you're going to be using in process flows. So now we are able to point to these objects, and that comes in very handy, because what we're going to be doing now is creating a task sequence. And this could be one of the trickiest parts of working with the process flow, but Flexim helped us make it easier. One piece of advice is, when you create a task sequence, remember to always have these 3 objects: the create task sequence, finish it, and dispatch it, or else it's not going to work. Let's go ahead and do it. So who are we going to use? Remember that we already referenced the operator by using the label called picker. The task sequence, we're going to call it inspection. And the task executor, who's going to be executing this task? The picker. Let's just keep those names along the task sequence. So what's the name of the task sequence again? It's called inspection. In dispatch, what's the name of the task sequence? Inspection. And who's gonna execute it? The picker. So before making anything more complex, I'm gonna audit my task sequence. Nothing's gonna happen, but if it flows all the way to the audit, that means that it has performed it correctly. And if you see here, there's a label that's been created that's called inspection. Don't worry about the information carried in there. It's just something that it uses to reference the number of the task sequence. So right now I have my framework ready. So now I want to create the actual task. So I want to ask the operator to walk to the buffer right there and do the inspection. And the inspection will take time. That's why we're going to be using a delay and squeeze it right between the travel and the finish. The operator, the task sequence is called inspection. And what's my destination? Remember, it's called buffer. That's where I want to walk to. Then in the task called inspection, I want to perform the inspection that's going to take maybe 60 seconds, just arbitrarily. And he's going to be inspecting. Exactly. That's what he's going to be doing. So let's see what happens. So not much to see over there because he traveled to the buffer and he was already there. So if we want to be a little more specific, what we could do is we could ask the operator to walk right to every pallet and inspect it. And we can do that by asking each of the tokens or each of the tokens to request the operator to travel not to the buffer but to the specific item. And I believe that we have a reference to the object, to the pallet. So let's see if we can use that. So if you see here, we have a reference to the object by using the label pallet. So that's exactly what we're going to do right now. We're going to ask the operator to run to what's called token.pallet instead of the buffer. Let's see what happens. Okay, so now the operator is doing exactly what I wanted. It's a little more dynamic, and he is done. So we can go ahead and continue with the logic. So that's why we want to use again the batch activity. Then we want to open the output. Before that, let's configure the 10 quantity. We want to release all of them. I did this because if I don't, every time the inspection is concluded, it's going to advance to the next activity, and I don't want that to happen. I want it to be stalled in this step until we're all done, and then we can open the output, or else my pallets are gonna leak out of the buffer. So we're gonna do this, open the output port, and then we're gonna use this specific activity right here that's called wait for event, because I only want my inbound port to be open once this is completely empty. So what I'm gonna do is I'm gonna do this. Let's say on exit, every time a pallet is moved out of the buffer, I want to do something. Let's say let's monitor the contents. There we go. Every time the content of the buffer changes and it decreases to or through the value 0, I want the tokens to be released. But only then. Let's see if this happens, okay? So we can audit it before doing any additional work. Ooh, okay, so yes, it did exactly what we wanted. But first, I don't feel very comfortable with this. I'm gonna be using current as my reference. Let me just check that it's working that way, because if for some reason these buffer changes names and I'm not using that reference, that relative reference, I might lose connection with the buffer. But if I do it like this, the model knows every time, it knows that current is stored right here, and if this object is exactly this one. And guys, make sure that this first activity is also referenced as current, or else when we copy this process flow to another object, it's not going to work, because it's going to be pointing to this queue originally. So this is very important. I'm going to open the input. So here goes a tip for you guys. One way to manipulate the activities in a process flow is by clicking, pressing and holding the control key, and that way I can remove an activity when it's already in an activity block, or else you're gonna have to use the scissors. So what are we gonna do here? We're gonna open the input ports. So after we have tested our process flow and it's working properly, we really want to replace that audit activity with sync, so that all the tokens leave through there, or else there maybe hundreds or thousands of tokens are gonna be accumulating there, making the simulator run slower. Today we completed a second pass on our DC inbound processes. We enhanced it both visually and with detailed inspection process by using a process flow. But we are not finished yet. These are the key topics we reviewed today. Keep these notes close to you so you know what video to return to. But just in case you don't worry, we got you covered. You will also find the key concept listed in the comments section. Come back for the next video, where we will be completing our inbound flow by distinguishing between SKUs and adding some policies to our put away process. This is really simulating the distribution center, the first block of really simulating the supply chain, part of Supply Chain's simulation series. Subscribe to our channel and activate notifications so you don't miss the next session, where we will continue to build simulation skills and better knowledge of the software. Cheers!